This is our automobile greenhouse gas emission analysis and prediction system, which is based on deep learning. This system aims to track and forecast CO2 emissions for fleets and personal vehicles, with analytics, dynamic maps, carbon tax calculations, a carbon trade market where users can pay to offset their carbon footprint, compliance reports, and weather integration, all in one system. Let's begin with the simple sign-up and login process. The sign-up feature requires your first name, last name, username, email, and password. To sign in, simply input your username, email, and password, and afterward, hit the login button. Once you're logged in, welcome to the dashboard. Here, you'll find key information about the system. Originally, this system was designed for companies with fleet vehicles, while personal users are limited to 3 vehicles. Over here, you can see the total number of vehicles registered in the EVIS system, including both active and inactive units. Right below, we have active monitoring, which tracks vehicles currently being monitored. We collect data on CO2 emissions, fuel consumption, and driving status every 5 minutes. In addition, the CO2 reduction section compares emissions over the past 6 months. We'll temporarily skip the real-time monitor and move on to fleet management. As mentioned earlier, personal users can add up to 3 vehicles. Within the fleet management section, users can view, edit, add, or delete vehicle profiles. It's designed to be very straightforward. Next, let's explore the analytic engine. Notice that the data visualization can be expanded to full screen mode. Just click here to enable it. To begin, you can filter vehicle information by year, make, and engine size by adjusting the filters. The system presents real-time metrics such as average CO2 emissions, GKM, average displacement, liters, total model units, and manufacturer data. Furthermore, the top 10 vehicles with the highest CO2 emissions are displayed in a table, which can also be downloaded. This pie chart, for example, illustrates the percentage of emission distribution by vehicle type. Further down, there are additional analytics like histograms, average CO2 metrics, 3D emission analysis, and engine size versus CO2 emission comparisons. Below that, you'll find the CO2 emission forecast table from 2025 to 2029, generated using CNN LSTM, RNN, and GRU models. Finally, in this section, we have the carbon tax summary. Moving forward, let's take a look at the personal CO2 calculator. The first step is vehicle selection, where users input or choose their vehicle details. Once that's done, they can view their specific emission data. Afterward, in the advanced forecasting section, users can choose different training models, set the carbon tax rate per ton, and define their annual driving distance in kilometers. Upon generating the forecast, the results appear on the right side of the screen. Lastly, the comparative emission analysis allows users to compare their vehicle with similar models. Now, let's navigate to the dynamic map here. Users can input the vehicle's make, model, year, and distance to estimate emissions produced over a given trip. In the emissions by year and country section, users can select a start year and end year, choose a country, and calculate global emissions. Additionally, they can search by country to access historical and predicted CO2 emissions data, starting from the early 1900s up to 2023, with forecasts extending from 2025 to 2040. Moreover, users can switch between different map layers for better visualization. And right below, the top emitters leaderboard allows users to select a year and the number of countries they wish to display. To briefly summarize the remaining sections, Part 6. Generate, manage and analyze environmental impact reports. Part 7. Access historical environmental data. Part 8. Check local weather and weekly forecasts through weather integration. Part 9. Review. The compliance report, which shows whether a fleet or personal vehicle meets CO2 emission regulations. Finally, for Part 10, the Q&A section. For any questions or technical issues, you can reach out to the support team. About our team: Jerry, team leader and data engineer; Shandy, visualization specialist; Brandone, back-end engineer; Patrick, deep learning engineer; Winston, front-end engineer. Thank you for watching.